Greetings and salutations, everybody. This is Jacob. Okay, so how the heck do we go about solving this problem? Looks complicated. Actually, it's much simpler than it looks, my friends. So first, let's turn our attention to this portion of the elastic band, the one that's not wrapped around the circles. If we draw a line segment that connects the centers of these two circles here, then the line segment is equal to 2r. And clearly the length of this portion of the elastic band is 2r, as you see here. So now let's turn our attention to the portion of the band that's wrapped around the circles, which is the trickier part of this problem, my friends. To figure this out, we need to find this angle here, theta. So how do we do that? Let's first turn our attention to the triangle that connects all three circle centers. This is an equilateral triangle, as you see here, and hence all the angles are 60 degrees. And so this adjacent angle here is 180 minus 60 equals 30, because of the total degrees of the angle of a straight line is 180, as we know. So ABCD is a rectangle, hence this whole angle here is 90 degrees. Hence this angle here is 90 minus 30 equals 60 degrees. Therefore theta equals 180 minus 60 equals 120 degrees. Since the entire angle of a straight line is 180, as we know, now that we have our desired angle, now we can calculate the arc length of the elastic band wrapped around the triangles. The formula for the arc length of a circle segment is L equals theta times pi times r over 180. So we have L equals 120 times pi times r over 180, which is 2 pi r over 3. So the total length of the elastic band wrapped around the three tangent circles is L equals 3 times 2r plus 3 times 2 pi r over 3, which is 6r plus 2 pi r, which is 2 pi plus 6 times r. And that's your answer. 2 pi plus 6 times r. Quite an intuitive answer, if you ask me. See, what did I tell you? Easier than it looks, my friends. Easy peasy lemon squeezy, as they say. And it was so easy I debated whether or not to make a video about it. In the end, I decided for it because I figured, why the heck not? I need to include some easy puzzles here and there once in a while, or most people will run for the hills. Plus, it looks pretty intimidating at first. When I first started trying to solve this, I expected it to be a lot harder, but it's not actually. I have harder geometry puzzles on this channel that are homegrown, but I recommend you attempt to solve this before you go to these other ones, like the circle that rolls around the two other overlapping circles, and that other one that has three circles inscribed in an equilateral triangle. So solve this first and then go to the other ones if you want something harder, my friends. Yeah, like I said, it looks a lot more menacing than it actually is. If this problem were a dog, for example, then it would be that annoying little dog down the street whose bark is a lot meaner than its bite. Oh yes. I hope you liked it. It was pretty interesting. The eulogy of this problem is probably going to be longer than the problem itself. Well, that's pretty much it. Smash those buttons like there's no tomorrow. You know the drill, my friends. Send a puzzle suggestion if you have one. I'm more than happy to showcase such puzzles that you're fond of, puzzles that may trouble you. And I'll see you guys in the next video. Bye-bye.